Welcome to our channel, my dear students. Today we are going to talk about the previous year, that is last 10 years CBSE Board Chemistry Questions Part 12, in which we are going to discuss about the alcohols, phenols and ether chapter. Here the question number 1 is, how would you obtain ethane 1,2 diol from ethanol? This question was asked in the year of 2013. So first of all, we have to write our reactant and product. So from ethanol, so I have to, my reactant is CH3, CH2, OH. This is the ethanol. My product is, so CH2, CH2, here it is OH. So here it is OH. So I'll be getting ethane 1,2 diol. This is my product. So let's see the reaction. So here initially I have, what is that? CH3, CH2OH. So CH3, CH2OH. In presence of acid, if suppose if I used concentrated H2SO4, the H plus will reduced by H to SO4. By that way, this H plus will come and attack this, and which will be eliminated as water molecule. By that way, I'll be getting a product as ethene. So I'll be getting a product as ethene. Once the ethene is getting formed, now it will be reacting with CCl4 and Cl2. So I'll be getting a product like this: CH2, CH2, here Cl and Cl. That is nothing but 1,2 dichloroethane I'll be getting. So once we used CCl4, chlorine in presence of CCl4, I'll be getting, what is that, 1,2 position I'll be substituted with chloride. So now, and the next thing is I have to use KOH, aqueous KOH I'll be using. So what is the role of aqueous KOH? I think so you all well know about that. Suppose if you don't know about that, please go and watch my previous video, which is the difference between aqueous KOH and alcoholic KOH. So here if I used aqueous KOH, there will be it will be this OH minus will act as a nucleophile. That nucleophile will come and attack the carbon. By that way, it replaces the chlorine. By that way, I will be getting a product that is CH2, CH2, here it is OH, here it is OH. So by that way, I will be getting 1,2 ethane diol. So ethane 1,2 diol, I will be getting the product. And next question, how would you obtain acetophenone from phenol? So I have to write the phenol structure initially. So this is a structure of phenol, OH. And I have to get acetophenone. Acetophenone in the sense, it's nothing but this is a benzene ring. Along with that, C double bond O, CH3. This is the aceto group and this is the acetophenone. So it's nothing but acetylation reaction. So before that, I have to convert this phenol into benzene. After that, I have to acetylate it with using Friedel-Crafts reaction. Now I have to convert this phenol into benzene. For that, I have to using zinc dust. So once I use the zinc dust, which will be getting eliminated as zinc oxide, by that way I'll be getting a product like benzene. So I'll be getting a benzene. Now the benzene is reacting with, so what kind of reactant? So benzene will be reacting with, what is that? CH3, C double bond O, Cl in presence of AlCl3. So if I used acylation, reaction, I will be getting a product like this. This is the product I'm getting, that is called C double bond O, CH3. This is nothing but our acetophenone. Are you able to understand, student? It's nothing but acetylation reaction. And third one is orthonitrophenol has lower boiling point than that of the para-nitrophenol. Why? They are asking. So first of all, we have to write the structure of orthonitrophenol and para-nitrophenol. So in which orthonitrophenol, so if I am consider, so this is the benzene ring, here it is O and H is there. Okay, and nitro group, if I am taking a nitro group, there is a N double band O and here single band O. Okay, this is a nitro group. Now that hydrogen bond is existing between these two. So because What is the meaning of a hydrogen bond? If the hydrogen is placed, suppose if I consider this as a hydrogen, if I consider this hydrogen is placed in between two highly electronegative atoms. That time it will be called as hydrogen bonding. That exceptional case, there is only the hydrogen bonding existing between highly electronegative atoms such as oxygen, nitrogen, fluorine. That we know that O and F, that is on-off system, on and off. You can remember it. That is a trick for identifying a hydrogen bonding. If the hydrogen which is placed in between these three atoms, that time it will be called as hydrogen bonding. Here the hydrogen bonding will be taking place. Now I am going to take what is a para-nitrophenol. So I will be taking a para-nitrophenol. So here also one OH group is there. Along with that N double band O, single band O is there. Okay. Now this will be existing between the two molecules. If I am taking N double band O, single band O, if I am taking single band O and double band O, along with that OH group. So here now we should identify this is a intramolecular hydrogen bonding. This is a intramolecular hydrogen bonding. Why it is called as a intramolecular hydrogen bonding? So the hydrogen bonding which will be taking place within the molecule. Within the molecule the hydrogen bonding is taking place. That is what this will be. This hydrogen bond somewhat it is very weak when compared to this intermolecular hydrogen bonding. This is called intermolecular hydrogen bonding. Why it is called as intermolecular? Intermolecular hydrogen bonding. Why it is called intermolecular hydrogen bonding? So the hydrogen bonding which is taking place between the molecules, here between the molecules, here within the molecules, that is the difference between these two. So this is the between the molecule the hydrogen bonding will be existing. That is what, so here the hydrogen bonding will be very strong between these two. So here the boiling point is very high for this para-nitrophenol when compared to orthonitrophenol. That is what it has high boiling point. Okay. By that way it has very low boiling point. This is because of that intramolecular hydrogen bonding, and that is nothing but the within the molecule itself the hydrogen bonding is existing. But in this case between the two molecules the hydrogen bonding is existing. That is called intermolecular hydrogen bonding. That is what will be very, very strong force. Strong bonding is there. That is what it has a higher boiling point. Are you able to understand, students? Okay. And next one is give the chemical test to distinguish between benzoic acid and phenol. First of all, we have to write the structure of benzoic acid. So this is the structure of benzoic acid. So here C double band O OH. And the phenol. I am taking a phenol. Now we have to find the difference between these two. If it is react with NaHCO3, sodium bicarbonate, it will give carbon dioxide. That is effervescence. Strong effervescence like CO2 is getting eliminated in the form of gas. But if it is react with NaHCO3, there is no reaction. There is no reaction. That is what we can identify these two, distinguish between the benzoic acid as well as phenol. So once I used sodium bicarbonate, I will be getting carbon dioxide as a good effervescence. That is what I can identify. This is a carboxylic acid. But phenol does not involve this reaction and does not eliminate what is that carbon dioxide. So that this is one of the good tests for identifying these two. And orthonitrophenol is more acidic than orthomethoxyphenol. Why? So first of all, we have to write the structure orthonitrophenol. Orthonitrophenol in the sense, so I have to take a phenol, along with that NO2. This is the orthonitrophenol. Then orthomethoxyphenol. Orthomethoxyphenol in the sense the methoxy group is existing. There is OCH3 group is existing. So here we have to see very carefully. So the entire group is common. Okay. So here the entire group is common. The only difference is NO2. Here the only difference is the NO2. Here the only difference is OCH3. Now we have to find out the difference between these two. This is nothing but this is a electron withdrawing group. But in this case here it is the electron donating group. As we know that if benzene ring, if phenol, in the case of phenol, if one electron withdrawing group is there, at that time the formation of phenoxide is very better. So once the formation of phenoxide is better in the sense, so it will involve in resonance structure which will disperse the negative charge through in ortho and para position. But in the case of electron donating group, which will intensifying the electron density on a particular place. That is what here ortho nitrophenol is more acidic, because in presence of NO2, that the pulling of this H plus, the removal of this H plus will be very easy because of both are electron withdrawing group. But in this case here one electron donating group is there, one electron withdrawing group is there. That is what, so it will having less acidic in nature, so which has more acidic, high acidic in nature. Are you able to understand, student? So once it is attracted with the electron donating group, that means the phenoxide ion is stabilized by this NO2 group. But here destabilizer will be this OCH2 will be acting as a destabilizer. That is what which is having less acidic in nature. It is less acidic in nature. Are you able to understand, student? Okay. And next question is, how would you convert ethanol to ethene? So this question was asked in the year of 2011. So here, how would you convert ethanol? So ethanol to ethene. So our ultimate reagent is ethanol, CH3CH2OH. This is our ethanol. So I'll be getting converted the product as ethene. Ethene is nothing but CH2 double bond CH2. How it is getting converted? So it is very simple reaction. Now we can say, so here I can write this CH3. So CH2H I'll be writing like this, and C, so here it is H, here it is H, here it is OH. I'll be taking in presence of acid. In presence of acid. So for example, concentrated sulfuric acid. So here it is a concentrated H2SO4. It will give H plus ions. Now, as we know that this H plus ion will come and attack because it has lone pair of electron. This OH group will have a lone pair of electron. The lone pair of electron will be given to H plus. So by that way, I will be getting CH2, one H is there, and here C, H2 is there, O. So here one hydrogen is there, already there, and one more hydrogen is adsorbed. So because of that donation of this lone pair, it attains positive charge. Now as we know that, which will be in a single carbon, in single oxygen, two hydrogen is existing. So that is, it is preferentially removed as water molecule. So if it is removed as water molecule, it got positive charge. Why it got positive charge? Because it want to remove as water molecule. So this bond is getting break. So this will be getting in the form of minus. This minus will be goes and neutralize this in the removed in the form of water. Now this got positive charge. Now I will be getting CH2H single bond CH2. In the top I have positive charge. Now this is an unstable one, so that it wants to, H plus wants to remove as its own. It will be removing as H plus. By that way, this bond is getting cleaved. It will be getting negative charge. Now these negative charge and these positive charge will form a bond. By that way, I will be getting a product CH2 double bond CH2. Ethene is my product. Are you able to understand, students? Please. So thank you so much for watching. Please forward my videos to others to get benefit. Don't forget to subscribe my channel. Thank you so much for watching. Thank you once again.